Next we'll see about next basic element, that is a type modifiers. Now, what are type modifiers? Type modifiers are the one which will modify the structure of the data type. So what do you mean by that? Now, if you take an integer actually occupies 2 bytes. So I want that integer to occupy 4 bytes because I would like to store a bigger value, because in a normal integer, it is going to, the maximum value you can store is 32,767. But if I want to store 1 lakh or 10 lakh or 20 lakhs, actually I have to increase the memory to store the bigger values. So instead of 2 bytes, I want the integer to occupy 4 bytes. Same way, normal integer, what happens is the last bit is been used as a sign bit. So assume that you don't have any negative numbers at all, then why to waste the sign? But I would like to use that even sign bit as a data bits. That means all 16 bits should be treated as a data bits. Okay. So that is, if you want to modify the structure of the data type, that can be done through this type modifiers. There are totally 4 type modifiers available in C language. So first one is unsigned, second one is an unsigned, then short and long. These are the 4 type modifiers. Now, whenever you give here just as an integer of x, by default it takes it as signed and short. So if you don't mention whether it is signed or unsigned, always the default one will be taken as an signed. Same way, if you don't mention here whether it is in short or long, the default will be taken as an short. That means whenever I give here int of x, okay, whenever I give it as an int of x, this will be taken as an signed short int of x. Means when it is unsigned, the last bit will be used as an sign bit, okay, and short, we are asking it to occupy 2 bytes. But the same thing, if you apply this unsigned, then there won't be any sign bit. All the data bits will be used as all the bits will be used as a data bits. So here, when I give an int of x, this will be taken as a signed short int x. That means number of bytes allocated is going to be 2 bytes. Number of bytes will be allocated as 2 bytes. In this, that means 2 bytes means 16 bits. In the 16 bits, 15 will be used as data bits, and the last will be used as an sign bit. Okay. And the range of value you can store here in this signed short int x is going to be minus 32,768 to plus 32,767. That is the range of value you can store in an signed short int x. So assume that I do not have any negative numbers. I want all 16 to be used as in data bits. That can be achieved by applying here as an unsigned. You can just give it as an unsigned int of x. Here you have, in this case you have mentioned as an unsigned. So when you are mentioned as an unsigned, then it takes as an, instead of taking signed, it automatically takes as an unsigned. And you didn't mention whether it is in short or long, so by default it will take it as in short. That means the overall it takes it as unsigned short int of x. So in this case here again 2 bytes has been allocated. Of these 2 bytes, all 16 bits will be used as data bits. You won't be having any sign bit, that is 0 sign bits. There won't be any sign bits. When there is no sign bit, the values cannot be negative. The value will be only positive. It starts from 0. This goes up to 2 raised to 16 minus 1. That is 2 raised to 16 minus 1. That comes down to an 65,535. That's the maximum value which you can store in an unsigned short int x. Sometimes you would like to store a bigger value. So if you want to store a bigger value, that cannot be done through an short. Bigger value in the sense more than 65,535. In such a cases, instead of 2 bytes, you have to make the integer occupy 4 bytes. That you can do it by applying long. So it can be done like this. You can just specify it as an long int of x. So when you give a long int of x, you didn't mention whether it is signed or unsigned. So by default, it takes as an signed long int of x. It takes as a signed long int of x.